Hello everyone, welcome back to the channel. Today we are going to learn how to convert a galvanometer into an ammeter and also a voltmeter. Galvanometers, ammeters and voltmeters. A galvanometer is a sensitive instrument used to detect and measure very small electric current. An ammeter is designed to measure much larger current in a circuit. For this reason, an ammeter is usually connected in series with the resistor or other circuit component through which the current is to be measured. An ammeter must have a very low resistance compared with the resistance of the rest of the circuit component so that it does not introduce significant additional resistance and alter the current being measured. A voltmeter is used to measure potential difference. It is always connected in parallel with the resistor or other circuit component across which the potential difference is to be measured. A voltmeter must therefore have a very high resistance compared with the resistance of the circuit component, so that it draws negligible current and disturbs the circuit as little as possible. Conversion of a galvanometer into an ammeter. A galvanometer can be converted into an ammeter by connecting a suitable resistor of low resistance in parallel with it. This resistor of low resistance is known as a shunt. The purpose of the shunt is to allow most of the current to bypass the galvanometer so that only a small and safe fraction of the total current flows through the galvanometer. Let's take an example. Suppose we have a galvanometer of resistance 8 ohm, which give a full-scale deflection when a current of 25 milliampere flows through it. We want to convert this galvanometer into an ammeter capable of measuring current up to 5.0 ampere. 5 minus 0.025 is equal to 4.975 ampere. That means out of the total current of the 5 ampere, only 0.025 ampere will pass through the galvanometer, while the remaining 4.975 ampere will pass through the shunt. The resistance of the galvanometer Rg is equal to 8.0 ohm. The full-scale current of the galvanometer Ig is equal to 25 milliampere, which is 0.025 ampere. The maximum current to be measured, I, is equal to 5.0 ampere. Since the galvanometer and the shunt are connected in parallel, the potential difference across both is the same. The potential difference across the galvanometer is V is equal to Ig multiplied by Rg. Substituting the values, V is equal to 0.025 times 8, which is equal to 0.20 volts. Let the resistance of the shunt be Rs. The potential difference across the shunt is also V is equal to Is times Rs. That is 0.2 is equal to 4.975 times Rs. Solving for Rs, Rs is equal to 0.20 divided by 4.975. Rs is equal to 0.040 ohm. In practice, an ordinary 5 ampere ammeter has this shunt permanently connected inside the instrument casing. Conversion of a galvanometer into a voltmeter. The galvanometer described earlier has a full-scale deflection of 0.025 ampere and a resistance of 8 ohm. The potential difference across the galvanometer is given by V is equal to IR. V is equal to 0.025 times 8 equal to 0.2 volt. This means the galvanometer can be used as a voltmeter, provided the readings are interpreted accordingly. In some instruments, two scales are engraved, one in milliampere and the other in millivolts. To measure higher potential difference, a resistor with high resistance, called a multiplier, is connected in series with the galvanometer. With this arrangement, the galvanometer is converted into a voltmeter. For example, suppose a galvanometer has a resistance of 100 ohm and give a full-scale deflection when a current of 5 milliampere flows through it. We want to convert the galvanometer into a voltmeter that can measure up to 8 volts. The potential difference across the galvanometer is Vg is equal to IR. Vg is equal to 0.05 times 100 equal to 0.5 volt. Since the total potential difference across the galvanometer and the multiplier must be 8 volts, the potential difference across the multiplier is 8 minus 0.5 equal to 7.5 volts. Let the resistance of the multiplier be R. Because the galvanometer and the multiplier are in series, the same current flows through both. So R is equal to V over I. R is equal to 7.5 divided by 0.05. R is equal to 1500 ohm. When this multiplier is connected in series with the galvanometer, the instrument becomes a voltmeter, capable of measuring up to 8 volts. And that is it. You now know how to convert a galvanometer into both an ammeter and a voltmeter. If you found this explanation helpful, like, subscribe, and hit the bell icon for more physics explanation. You can also drop a comment below. Thanks for watching. I will see you in the next lesson.